Okay, dear students, today we shall discuss this problem which says that show that all four root of this biquadratic equation cannot be real. So it implies, in other words, we can say that there exists at least one imaginary root for this equation. And in this equation, what we are not known of are a and b, which are given. The leading coefficient a should not be 0 and ab can take any real values otherwise. Alright, then let's proceed for the problem. Actually, in this problem, we can say that if a and b are not known, so it's quite difficult to form an implicit function that says that we can plot this graph. So since a and b are not given, so by guessing them we will have to make many cases which includes a positive, b positive, a negative, b negative, and all those four cases in which a b both negative, a b both positive, a negative, b positive, and all that. So now let's use some different approach. Consider x1, x2, x3, x4 are roots of equation. Let us say these are the four roots of this given equation. Now let's find equation having roots 1 by x1, 1 by x2, 1 by x3, 1 by x4, which can be easily found by replacing x by 1 by x. Hence it becomes x power 4, x power 3, x square plus bx plus a equals to 0. So this is the equation which have its roots as 1 by x1, 1 by x2, 1 by x3, 1 by x4. That is the reciprocals of the roots of the original equation given. Now let me find the squares of some of these roots, that is summation 1 by xi squares. That can be given as summation 1 by xi whole square minus 2 times sigma 1 by xi xj I not equal to j. Alright, so that's actually sum of the pairwise products of the roots. So what is sum of the roots? Sum of the roots of this equation is minus 1. Here we are taking the square. Now minus 2 times. What is the pairwise product sum of this equation's roots? That is also plus 1 actually. So here we come to know that this is 1 minus 2 minus 1. Hence we can say 1 by x1 square plus 1 by x2 square plus 1 by x3 square plus 1 by x4 square is negative of unity. Now it's a very simple logic. Now you need to apply that if they all were used to be real numbers, if they are all real numbers, then how come their square sum can be a negative 1? Hence at least one of them is not real. Since this equation originally had all the coefficients real, leading coefficient a and that unknown b is also real, and other three coefficients are all 1. So all the coefficients of this equation are real. Hence if exist, imaginary roots will be always in conjugation pair. So at least two roots of this equation are not real. So that's the proof.